In order to write the equation of a parabola passing through these points, I need to recall what the equation of a parabola in standard form looks like. In standard form, a parabola is y equals a number times x squared plus a number times x plus a constant. So my answer has to be in this form. I need to figure out an a value and a b value and a c value so that my parabola goes through these 3 points. In order to do that, I'm going to think of these ordered pairs as input-output functions. If I input -2, my output has to be 10. If I plug -2 in for x, my output, my y, has to be 10. So that's where I'm going to start my process. I'm going to start with my first point, and I'm going to plug in -2 for x. And for an output, for my answer, my y value, I'm going to put 10. This is kind of like one of the methods we used to solve for b when we were writing the equation of a line, where we knew the slope of the line and a point that it passed through. We plugged in our x value for x and our y value for y and solved for b. In this case, we're going to have to solve for a, b, and c. Let's simplify. -2 squared is positive 4 minus 2b plus c equals 10. Now I'm going to go to my second point, 1, -2. Plug in 1 for x, and my output, my y, is going to be -2. One squared is a, b times 1 is b, plus c equals -2. And finally, my last point, 2, 6. Plug in 2 for x, and for an answer, I'm going to get 6. Simplifying that down, I get 4a plus 2b plus c equals 6. So if you look, there's 1, 2, 3 equations with 1, 2, 3 variables. So we have a system of equations, but instead of solving for x, y, and z, we're going to solve for a, b, and c. Now to solve a system of equations, we have multiple methods. We could use substitution, where we solve one equation for one variable and plug it into the other 2 systems. We could do linear combination, where we multiply each equation by numbers to eliminate one of the variables. We could solve the system using inverse matrices, set up a matrix equation, and solve for a, b, and c. Or the method that I'm going to choose, Cramer's rule. I could pick any of these. I'm just going to pick Cramer's rule. To use Cramer's rule, I'm going to first come up with a coefficient matrix. I'm going to call that coefficient matrix capital A. And the coefficient matrix is going to be a matrix made up of all my coefficients of my variables a, b, and c. And then I'm going to find the determinant of that matrix. For time's sake, I've already entered in this matrix into matrix A on my calculator. And I'm going to use my calculator to find the determinant of matrix A. Next, I need to set up an x matrix. But in this case, I don't have an x variable, I have an a variable. So I'm going to set up a matrix that I'm going to call lowercase a. Not to be confused with capital A, lowercase a is my coefficient matrix with my a column replaced with my answers, 10, -2, and 6. And I need to find the determinant of that matrix. Again, for time's sake, I've already entered that matrix into my calculator, and I'm going to use my calculator to find that determinant. Next, I need to set up a y matrix. But I don't have a y variable, I have a b variable. So I'm going to call this matrix lowercase b. And I'm going to take my coefficient matrix, but this time replace my b column with my answers. And keep all the other columns the same. And I need to find the determinant of that matrix. That matrix is already entered into my calculator, and I'm going to use my calculator to find that determinant. Finally, I need to set up my z matrix. In this case, I don't have any z variables, but I do have c variables. So I'm going to set up my c matrix by replacing my c column with my column of answers, 10, -2, and 6. And then I'm going to keep my a and my b column the same. And then I need to find the determinant of that matrix. Use my calculator to find that determinant. I get 48. Now I need to solve for a, b, and c. A is going to be this determinant divided by my coefficient determinant. B is going to be this determinant divided by this determinant. And C is going to be this determinant divided by this determinant. So I have -36 divided by -12 gives me +3. 12 divided by -12 gives me -1. And 48 divided by -12 gives me -4. So I've solved for A, B, and C. My final step is to write the equation of my parabola. And I want to write my equation in standard form. Well, I did all this work to solve for my A, B, and C. I need to plug it back in to write my equation. Y equals 3x squared minus x minus 4. I can check my answer by graphing this parabola. Go to y equals. If you have a plot turned on, scroll up, hit enter, turn off that plot. If none of your plots are turned on, you're fine. Clear out what's ever in my y equals and enter in 3x squared minus x minus 4. And I'm going to go to zoom standard. And to check to see if this is correct, I'm going to go back to my original points. This parabola should hit my 3 original points. So I'm going to hit the trace button, and if I scroll left or right, my cursor is going to trace on my parabola. And I want to test when x is -2. So I'm going to type in -2 and hit enter. And if I look, when x is -2, y is 10. So it hits my first point. And I can just hit 1 to test my second point. 1, -2. So it goes through my second point. And my third point. Yep, goes through all 3 points. So in order to write the equation of a parabola in standard form, I need to figure out my a, b, and my c. To do that, I'm going to set up a system of equations using these 3 points, and then solving that system of equations for a, b, and c. Finally, writing my answer in standard form.